Hello students, myself Archana Varude from Praveen Patel College of Diploma Engineering and Technology. In today's video, we are learning about what is elastic limit, what is meant by Hooke's law, and what are the types of model of elasticity. First we see what is by elastic limit. See these diagrams. By observing these diagrams, it is observed that when a rubber band is stretched, then there is a elongation in that rubber band, or when we stretched it, that means external force is applied, then due to that there is a change in its shape and size. But that change is not permanent change, it is only for some time. And also when we stretch spring, then it is observed that when external force is applied, then there is a change in its shape and size. But when force is released, then it again returns to its original dimensions, or it again returns to its original shape. That means it is observed that if the force is within limit, then there is no changes in its shape and size. But when large amount of force is applied, then due to that there is change in its shape and size. And therefore from that we write the definition of elastic limit as the stress corresponding to the limiting value of load, which when applied and subsequently released does not produce permanent deformation, is called as elastic limit. That means it is observed that when force is applied, and if that force is within elastic limit, then there is a change in its shape and size. But that change in its shape and size, it is not permanent change, it is only for some time, and as the force get released, then it returns to its original shape and size, and that stress is called as it is within elastic limit. And if this limit is crossed, then the proportionality is lost, and due to that the stress is found to be less than what is expected, and intramolecular structure of the body get collapse, and due to that there is a permanent change in its shape and size, that is called as permanent deformation. Then after that there is a law called as Hooke's law, and statement of that Hooke's law is within elastic limit strain is directly proportional to stress. As we know that stress means it is the ratio of applied force per unit area, and strain means it is the ratio of change in dimensions to the original dimensions. And this Hooke's law states that within elastic limit, that means if that force is within limit, then strain is directly proportional to stress, and therefore here we write strain is directly proportional to stress. Then when we take equal sign in next step, we get strain is equals to constant into stress. And if we take that stress on left hand side, we get stress upon strain is equals to constant, and that constant of proportionality is called as modulus of elasticity. And therefore we write modulus of elasticity is equals to stress upon strain. Then we write SI unit of modulus of elasticity. Here formula is stress upon strain. Therefore first we write the SI unit of stress and then SI unit of strain. And SI unit of stress is Newton per meter square, and strain has no unit because it is the ratio of two similar quantities, and therefore SI unit of modulus of elasticity is Newton per meter square, and CH unit of modulus of elasticity is dyne per centimeter square because strain has no unit. And this modulus of elasticity, it is divided into three types. First is known as Young's modulus of elasticity. Second is bulk modulus of elasticity, and third is modulus of rigidity. Now we see what is meant by Young's modulus of elasticity. And for Young's modulus, symbol is used as capital 1. And as we know that modulus of elasticity is stress upon strain, and when that force is within limit, and if we find the ratio of tensile stress to tensile strain, then that ratio is called as Young's modulus of elasticity. And therefore formula is Y equals to tensile stress upon tensile strain. Then we write the equation for tensile stress and tensile strain. Therefore it becomes Y equals to mg upon pi r square. This is the equation of tensile stress, and equation of tensile strain is small l upon capital L. And therefore final equation for Young's modulus is Y equals to mg capital L, that means original length, upon pi r square small l, where m is, that is the mass attached or load attached, capital L is original length of wire, r is radius of wire, and small l, it is the extension produced, that means change in length. And now we write the SI unit for Young's modulus. Here formula is tensile stress upon tensile strain. Therefore in numerator write the unit of tensile stress, and unit of tensile stress is Newton per meter square, and tensile strain has no unit, and therefore SI unit or MKS unit of Young's modulus is Newton per meter square. Then CGS unit of Young's modulus. Again formula is same, that is tensile stress upon tensile strain. Only difference is that we write CGS unit for tensile stress and tensile strain, and CGS unit of tensile stress is dyne per centimeter square, and tensile strain has no unit, and therefore CGS unit of Young's modulus is dyne per centimeter square. Second type is bulk modulus of elasticity. It is denoted by capital K. First observe these diagrams. Here this first diagram shows that this is the initial state of object, that means when force is not applied, when pressure is not applied, then at that time its volume is fixed. But when force is applied from any side, then that object is said to be, it is under pressure or it is under bulk stress, and due to that its volume get changed. There is a decrease in volume, and therefore from that we write within elastic limit, that means when the force is within limit, then if we find the ratio of volume stress to volume strain, that ratio is called as bulk modulus of elasticity. And therefore we write the formula as K equals to volume stress upon volume strain. Then formula for volume stress is F upon A, that is applied force per unit area, and formula for volume strain is dV upon V. And therefore we write K equals to dP, that means it is F upon A, upon dV upon V. And therefore final formula for bulk modulus is K equals to dP into V upon dV, where V is original volume, dV is decrease in volume or change in volume, F is applied force, dP is decrease in pressure, and A is area of cross section of wire. And now we write SI unit or MKS unit of bulk modulus. Here formula for bulk modulus is volume stress upon volume strain. Therefore first write the unit of volume stress divided by unit of volume strain, and SI or MKS unit of volume stress is Newton per meter square, and volume strain has no unit, and therefore SI or MKS unit of bulk modulus is Newton per meter square. And CGS unit of that bulk modulus, it is equals to dyne per centimeter square, because volume strain has no unit. Then what is meant by compressibility? It is observed that when pressure is applied, then due to that there is a change in volume. And here the compressibility, it is the property on account of which body can be compressed by the application of external force. And if we find the reciprocal of bulk modulus of elasticity, it is called as compressibility. That means opposite of bulk modulus. And therefore here we write compressibility is equals to 1 upon bulk modulus, and for bulk modulus symbol is K, and therefore formula becomes compressibility is equals to 1 upon K. Then we write the formula for K is dP into V upon dV. Therefore here we get compressibility is equals to dV upon V into dP. Or you may write that compressibility is equals to volume strain upon volume stress, because it is the reciprocal of bulk modulus. And therefore SI unit or MKS unit of compressibility is meter square upon Newton, because it is reciprocal of bulk modulus. And CH unit of compressibility is centimeter square upon dyne. Then now we solve some MCQs based on these topics. First question is, within elastic limit strain is directly proportional to stress. It is a statement of, option A is Hooke's law, option B is Stokes law, option C is Newton's law, option D is none of these. And as we see in the earlier slide, that is statement of Hooke's law, and from that statement, within elastic limit strain is directly proportional to stress, and therefore correct option is A, Hooke's law. Question number 2 is, the reciprocal of bulk modulus of elasticity is called as, option A is compressibility, option B is Young's modulus, option C is bulk modulus, option D is modulus of rigidity. And as we see that compressibility, it is the reciprocal of bulk modulus, and therefore correct option is A, compressibility. Question number 3 is, the ratio of volume stress to volume strain is called as, option A is bulk modulus, option B is Young's modulus, option C is modulus of rigidity, and option D is none of these. And as we seen here, bulk modulus, it is volume stress to volume strain, and therefore correct option is A, bulk modulus. Question number 4 is, stress upon strain is equals to, option A is modulus of elasticity, option B is Young's modulus, option C is bulk modulus, and option D is modulus of rigidity. And as we know that when we take the ratio of stress upon strain, it is equals to modulus of elasticity, and therefore correct option is A, modulus of elasticity. I hope you all understand these points, that is Young's modulus, bulk modulus, and modulus of rigidity. Thank you.